question?
Hey, good. Good.
Like, can you all see my screen?
Yes. Yes, we can. It's on the Piazza.
Oh, okay, good. If you folks are still joining, just joining. Hold on for a second. All right. Yeah. So today the plan was to go over the upcoming exam later this week.
Professor, could you go over the format of it?
Yeah, we're gonna go and look at an actual exam.
Okay, perfect.
From last semester. I think it's recording. Is it recording? Yeah, it is recording. All right, so I'll just admit others as they join. So the exam is gonna look something like this. There'll be lots of fill in the blanks or multiple choice or match, column left, column right, column. And they'll give you perhaps a code snippet and then ask you questions about that. Just keep adding folks. Just a second. So we're going to go over a few of these. So all of this is from the slides that are available on Canvas. So if it's not on a slide, then it's not in the exam. So and from various topics, some questions about Agile and different methodologies. Comparing. Agile versus waterfall or code and fix and other intermediate strategies that we've used for managing projects. Some questions about the Scrum methodology of what some terminologies mean of what Scrum means, what is the a stand-up meeting or a burn down chart or the velocity of a sprint. What is a sprint? So a lot of terminology of that, like that, and also about testing. About functional tests, different types of measurements of testing, whether it's branch covering or statement coverage. So might give you a piece of code and give you a couple of unit tests, and then ask you, what is the branch covering or statement coverage, and you to calculate it and within a particular ballpark, and give out choose from the right answer. So here's just a few questions. I'm going to start work my way up. So this, for instance, is a question that given a control flow where you have a couple of nodes, a couple of branches, and you don't necessarily it doesn't really matter what this function does. That's not the point. We give you a function, has a couple of parameters, and depending on the values of RST, it flows one way or another. And so, given this particular unit test of using 341, it causes the flow of the application to go one way or another, but some branches will not be covered, right? So 341 might cause only half of the nodes to execute, whereas if you have several other tests, if you have more tests, that it would cause a cumulative coverage of these statements or these branches. So the question is, okay, given that one parameter, what is statement coverage? And so the answer here is 50%. So it's within some reasonable value. It doesn't have to be exact. If it's 47 point something or whatever, it's roughly, what is the statement coverage? I think somebody's speaking. Wait. Let's see. I think somebody's not muted. Yeah, that's everything. So I give you a graph like this, or you can actually code. Well, again, some random piece of code. It'll be just some generic piece of code that doesn't do anything special, but usually has a few branches, statements, and typically you would draw this in a graphical representation so that you can look at the branches, and so the one of the tests might cause it to go through one of the if statements, and the other one might cause it to go to another set of statements. Now, because these has 3 branches, typically you would need at least 3 tests that would cause it to go through all 3 branches to get a 100% branch coverage. But since there are only 2, you can already guess that there might be at least one branch that is not executed.
Hi, Professor. So the branch coverage refers to how many nodes essentially you pass through in that graph you made.
Yeah,
earlier.
it also takes into account the true and the false that cause a particular branch to be evaluated as true and evaluated as false. So each branch, it has 2 possibilities, and so you have to consider all the inputs that cause that particular condition to be true and executes, or conditions to be false, right, and just continue elsewhere.
Okay. Okay, thank you.
Yeah, seems like it's just yet another little example of causing this one, and you either count all the branches that have been explored through your inputs, or the number of statements that have been executed, which is not necessarily the same. Now, if you have gone through all the branches, then you can guarantee that you have gone through all the statements, but not necessarily the other case is true, right? That you might have gone through all the statements, but not necessarily all the branches. This one is asking, given these 3 inputs, which statements have been executed. And this turns out that all statements have been executed. And so if you have 100% coverage. There'll be lots of definitions, questions on, for instance, terminology that we've been covering throughout the semester, like shifting left, right? And that, if you remember, that was a graph that predicted the cost of detecting a failure or a defect, right? The longer that it takes you to identify that defect throughout the process, the development process, the longer you take to identify it, the much more expensive it will be later down the road, right? The earlier you can catch that, the better, right? So that's where the shift left terminology comes in, right? Where shift left in time, right? And where left is the beginning of time, right? And as you move to the right, you know, you're prolonging the time it takes you to identify those defects. So this one said, well, what does it really mean with regards with identifying software defects? Well, shifting left refers to identifying defects earlier in the software lifecycle, right? So it's not a political left or right, like in the political sense, or social justice or whatever. It doesn't mean later; it's earlier, right? Earlier in the software cycle. So this is kind of asking the same thing, but in a different way. And again, it's referring to what happens to the cost. What are the impacts of you waiting, of identifying the defect early on, right? So the longer it takes, right, the more expensive it will be. It's much easier to identify a defect early on in unit testing and fix it there than that if that defect goes into production, right? And now the piece of software has been deployed, the client is already using it, right? Fixing something that is already in the field, that's not so much more expensive. So this one gives you some obviously wrong answers, that it decreases over time. Obviously not. This one gives you one that might be the case, where it grows at first, but then it just tapers out at the end. And that's not the case. So also questions about continuous integration, continuous delivery, and the various phases that each one goes through. And so if you remember, continuous delivery includes continuous integration, right? So continuous delivery has several phases, of which one of them is continuous integration. And continuous integration itself consists of running automated builds, automated testing, right? Whereas earlier than that, right, you have code reviews, right, where you have folks reviewing their code and unit testing and whatnot, right? You automate that as well. I think we have folks that have not muted. If you please all mute. Somebody's not muted. There we go. Still, when it's not muted. And I think there's a slide on that. I think it's this one. This one, right? If you remember, continuous integration is part of the continuous delivery, right? You have continuous deployment being the last part, you have continuous integration being in the middle, right? And the whole thing is referred to as continuous delivery, right? Which is made up of these two big buckets of tasks. So this is asking you, what is it that we do during continuous integration? What do we do during continuous deployment, right? And so questions like that. Also asks you all sorts of things about Agile, including certainly the things that we've been practicing for the last couple of weeks of using Scrum as being one of many implementations of Agile. So there are different activities that occur during Scrum or during Agile. and one of them is obviously documentation. And so one of the common things that happen in non-agile, in waterfall, in methodologies is that this is very document heavy, right? Where everything is documented, to very detailed, even though you might be documenting things that actually never get implemented, right? Or that they're documented in such a way that if they get implemented, they actually get implemented in a completely different way than they were documented. So on the other extreme, you don't do any documentation, right? It says, well, why document if things just are going to be, going to be stale? So Agile takes the approach that, yeah, well, I mean, we are going to document, right? But let's document in such a way that it's not burdensome. How could we document in such a way that it's not going to go stale? And so the truth of the matter is, whatever you actually end up implementing, right? That's what's being delivered, built, compiled, tested. So if the documentation can actually live in the documentation, in the source, that would be the best place to put the documentation. So Agile is takes the approach of the code itself is the documentation. So whatever additional comments you can add through JS doc or Java doc or whatever documentation tools you can add, you increment the quality of the source code and make it so much easier for other developers that are going to come behind you they're going to have to own that code. So that's one of the questions. So it says, so obviously, it says, Agile projects don't document since it will become obsolete anyway. No, that's not true. And so another wrong answer. Agile projects understand the importance of documentation. Obviously, documentation is important. And the feature the documenting features fully before implementation. That's not true either. Right? We might do some light documentation where we jump to the whiteboard and do some draw a couple of squares and lines, right? Enough to understand what it is that we're building, and then once we build it, right, we go back in and add some Java doc and finish up, polish a couple of documents, right, for later generations. So which are some of the benefits of Agile projects? Select all that apply. Allows requirements to be discovered as you go, mitigate risks, provide high level of confidence on how projects will ultimately conclude. No such thing. Unfortunately, we don't have that. We could give it intermediate confidence on how we are going, right, and that everybody is very well aware and informed on the decisions that we're making, and that we're all agreeing, right, and that we're making incremental progress. Yeah, that definitely. So you can feel good about where we are and where we're going, and that if we're going to be late, well, it's not going to be it's not going to be a surprise, right? We know it was a conscious decision that we incremented the scope, so obviously we're going to miss a date that we all agreed to move the date, right? So it gives you confidence of where you are and where you want to go, right? But who knows, right? It's very, very hard to predict things. And so Agile recognizes that, right? And says, well, it's foolish to try and predict so far ahead. It's not assume requirements are frozen. Things are changing. Is managing chaos, right? And instead of trying to control in such a way that is non-realistic. Which is the following characteristics of Agile self-engineering, right? Others, right? Initiate actions promptly, notice changes early. So all these things are from slides that we've seen. Obviously, the exam will be you can take a look at all the slides. Obviously, I would suggest that read through all the slides and become familiar with what the content is there, so that you can quickly jump back and forth. To say, yeah, I remember reading about that, and you can know where exactly it is, and you can take a look at it and be sure. Which are some problems of waterfall? Yeah, real projects rarely flow in a sequential flow, right? Frequent team demos cause delays. That's not the case, right? There are no frequent team demos. Frequent customer involvement throughout the process creates undue overhead. That's not the case, right? Because the customer is not involved throughout the waterfall process. Hard to state all requirements explicitly. That's true, right? We are stating all these requirements, but nobody really knows, understands them, and well enough to state in any detail. Short sprints don't allow, because there's no such thing as sprints in a waterfall. Also, some other terminology of using vertical prototyping, horizontal prototyping, right? And what are they good for? If you remember, horizontal prototyping was the case where we took a particular layer of the application and we focused on understanding that thoroughly, right? And implement it in such a way that we could simulate, the other layers, right? And just focus on that particular layer. We could mock the rest of the layers. If you're focusing on the front end or you're focusing on the middle tier, you could simulate the other tiers, right? So you can focus on that one tier and isolate it by mocking the other layers. Maybe if you're doing the middle tier, you could mock the database, right? So you can focus on your controllers, on your business logic, right? Or if you're doing the front end, you could mock the controllers, mock the services, so you can focus on the front end. Or vertical prototyping is the case where you want to prototype the entire a feature going all the way through multiple tiers, right? Starting at the front end, going through the middle tier, right, down to the services, right, layer, and then business layer, and all the way down to the database, right? Or all the dependencies that are needed for that particular feature. And those are really, really well suited for testing out either a new technology, a new approach, or interacting with a third-party API that you're not familiar with, and so you want to try it out just to give you confidence that's not going to negatively impact the project, right? So you do a proof of concept. Yep, using this new 3D rendering API, and which it's new to the team. So you might ask somebody to take a task and say, go do a vertical prototyping of some feature, learn about it, write a document and do a demo to the rest of the team, so that we feel good about using that API, right? So it's great for that. This unified process is one of the many methodologies, right? We've gone through code and fix, right? All the way down to what we're today, either extreme programming or agile, right? But in that history, we've gone through several methodologies, which one of them is the unified process that kind of tried to, it is the methodology that bridges the old legacy waterfall, right? And it identifies the need for breaking things into smaller, more manageable, iterative processes, right? Which is the precursor of what we have today, Agile, right? So a unified process is kind of like it's the it's where we started identifying the need of breaking up these large, huge waterfall processes into smaller, manageable phases. And so it's a precursor to what we have today, Agile. And we don't know what will come after Agile, right? Agile right now is everybody's using Agile, but we don't know what will come later. Right? You might be the ones who invent a new methodology, right? And will and it'll go viral, and then everybody will use your particular methodology because you discovered some new way of doing things, right? So the Agile is the precursor of whatever comes next, which we don't know what it is. Just like Unified Process was the precursor to Agile. And so the Unified Process identified several phases, right? The inception phase, the elaboration phase, this construction phase, transition, right? Which again, it was the it was the realization that waterfall wasn't really cutting it, and looking to break it up into smaller pieces, right? They this is the model that they came up with, where you do inception at first, where you do requirements gathering, a lot of analysis, design, business modeling. Eventually you move on to the construction phase, where you do just mostly implementation. You do unit testing, integration testing, right? And then eventually you taper up to deployment. So this is asking you, what are some of the phases of the unified process: construction, inception, elaboration. So definitely questions on Scrum, right? Where there are several terminology that we use in Scrum, as in stand-up meetings, sprints, right? Velocity, points, and tasks, and doing the different meetings. Sprint planning. You do retrospective meetings right at the end, and which we have been practicing for the last couple of weeks, right? So one of the terms that we're asking here is what is the sprint velocity, right? And so this is the average number of points that a team completes in an average sprint, right? Not the bugs that you fix, not the lines of code that you write, not the hours that a team completes, right? It's the number of points, right? Then other terminology, there's several laws that we go through. Dijkstra's law, Goodhart's law. There's a whole bunch of them that kind of have like these one-liners. These that capture the wisdom of these engineers as they've gone through project management and dealing with large projects over long periods of time. So Goodhart, what he was pointing out, that yeah, it's great to have metrics that allow you to see how you're doing, right, over time. But once you take that metric and you consider it as a target that says, oh, it's good to have these many points per sprint, right? But then if that becomes your motivation, then it becomes becomes an arbitrary measure, right? That it's no longer valid, right? It should be that you do whatever you normally do. You see that you are normally pumping out 100 points a sprint, but if that becomes your target, now it becomes artificial, right? That you might want to put in more stories or less stories because you know that your metric is 100, right? So it becomes a bad metric once it becomes a target. So that's, again, it's a nugget of wisdom from. And the slides have tons of these one-liners from lots of different people, and so just become familiar with them. Maybe you could create a little table where you list all these all these nuggets of wisdom from all these engineers, and then you can, as a reference, use them, because there will be a question, what did Goodhart say? What did Dijkstra say? Right. So this horizontal prototyping that we talked about a little bit earlier, about which is good for graphical user interfaces as an example, right? Where you take one layer, right? You prototype it and isolate it from the rest of the other layers, right? People are joining and they're not muting, I should say. Let's see. Oh, I see. There we go. Let's see what else. One of those measurements of taking source code and measuring how good is the source code, right? One of those measurements is cyclomatic complexity. That how many loops do you have, and branches, and inputs and outputs, right? And how many nodes do you have in your algorithm? We try to capture that and see and give you a score, right, on how complex is your algorithm or your function, whatnot, right? And so they have this analysis on successful projects and unsuccessful projects, and creating some kind of correlation between success and failure, and the complexity of the source code. And there have been several organizations that have done these studies, and a ballpark on what good complexity, cyclomatic complexity, is around 10. But again, right, if this becomes a target, right, then perhaps it's not a good design. It's not a good measurement, right? Because there'll be lots of edge cases that will not have this particular complexity, but the source code is good enough, right? Or people understand it enough, and they will subjectively consider the piece of source code to be a good piece of source code, right? But it has a large cyclomatic complexity, and so again, it should not be a target. It should give you a ballpark and say, "Ooh, well, maybe this could be rewritten in such a way that it's a less complex," right? So it should be just a guidance, right? And not necessarily a target. Right. So this goes back to the shift left terminology earlier about the cost incrementing over time. So what is more costly? Is it fixing the problem during the design phase, with the requirements gathering, when it's deployed already to the field? Well, like testing, obviously, it's more costlier when it's already deployed to the field. This is going through several of the challenges of the various software methodologies. If you remember this, we went through a whole bunch of them, right? Spiral, code and fix, unified, waterfall, obviously, agile. And so of any one of them, I might ask, well, what was wrong with these particular methodologies? Why do we ever stop using code and fix? And why do we have to move away from that and go to agile? And so here, I think there was a mistake in this question. This said select all that apply, but there were 3 options. It turns out that all 3 were correct, right? So what was wrong with code and fix is that there's no way to deal with complexity. There was no way to deal with separation of concerns. There's no way to formally measure the process of or documentation. So all 3 were wrong. Although it does have some pros, right? If you're just gonna build something that is kind of like throwaway proof of concept, and you're going to prototype something real quick, a quick and dirty thing, right? Then code and fix is perfectly fine, right? there's no overhead of over engineering and over designing something. You want to try out something really quick and just something over the weekend, just to show off your colleagues when you come back on Monday. Yeah, code and fix is perfectly fine, right? Just don't get into the habit or give in to the temptation of making it more than just a prototype, right? It's very common that the owner of a business comes in and comes up with an initial prototype using code and fix. It's working. It's bringing in money, right? He gets an initial set of clients that are paying, but now it needs to scale, right? It needs to become a real business, and you have to get it through real software engineers. They're going to come back and they're going to look at your source code, and they're going to roll their eyes and say, "Oh my goodness, what have you done?" Okay. So yeah, another example of Umatic Complexity. Okay, so this is using this. It's using this equation for complexity, right? Where you look at the number of edges. So any piece of software can be written, starting from the source code. It can be written as a flow diagram, and you can identify the number of nodes, number of edges, and then you can plug it into this equation. Calculate the number of edges, number of nodes, right? And then come up with a value of what the complexity is, right? So this saying, giving this little if statement with this nested if printing, what is the cyclomatic complexity? So just asking you if you know how to apply that function. So what is a burn down chart? Again, some terminology from using Agile and Scrum. Boehm first law, right? That when do most errors occur throughout a project, right? And when is also you also say that a project is most vulnerable during its requirements phase, right? When you're gathering the requirements, that just people agreeing on what it is that they're building and what are the things that they're not building, right? So that's about that. So this is what I asked you. So okay, so if waterfall is so bad, how can we make it better, or what principles can we apply to make waterfall better? So should we just add more people? Just add more people, right? Or get more money and better funding, or just we'll build a fire and sing songs, or just split the process into smaller incremental pieces, right, and be able to measure them one by one. So that's how Agile eventually did. So in the same vein, it's this same kind of the same thing, right? Which one is true? If a project is already late, right, and you add more manpower, the project increments. You're going to increment the chances of success? No, right? If it's already late, you're just going to make it even worse, right? Because the people that are already productive are going to now have to refocus their efforts into training the new people that are coming in. They're not familiar with the project, right? And so you're gonna be even later, right? Because you're creating more burden of the people that are already productive. Maybe not as productive as you want, but that's too late, right? It's already late, right? You're gonna make it even later. Maybe with more people. Unless you find ways that you could, cleanly, right, split up something and someone else can just work on something independently, then yeah, that might work, right? But if you need to, divert resources that are already being as productive as you can, right, into training folks. You're just going to be forced. So here's another. Towards the end, we talked about what's some of the strategies either individual developers can take to become more productive, and how to be a good citizen, within a team, right? And so one of the terminologies that we looked at is the 10x developer, right? You see some of these star developers, right, that we all look up to and admire. And so what are some of the characteristics of these star developers, right? They, one of the characteristics that they surround themselves with so they themselves surround themselves with folks who they can learn from, right? So they always they don't see themselves, might not see themselves as top developers. They might look up to someone else, right? Or in either remotely or read lots of articles about other developers, and and always in a learning phase, right? And so they see themselves as always improving and always looking for automating as much as they can, so that reduce the probability of making mistakes manually, right? So they identify patterns where that could be automated, right? And so I don't have to do manually. They'll do it manually the first time and says, "Oh, how can I automate this so I don't have to do it again?" Right? So they're always looking for tools, writing scripts, and just increasing their productivity. It's not, they're looking for, they work extra hours to get it done, right? Or they have to have higher education credentials, not necessarily, or they just have a higher IQ. No, not the case. Right? So this question was on some architectural questions. If you remember, we looked at different architectures and some of the fallacies that developers have or designers have about architectures, how they evolve over time, and administration and networking and whatnot, right? But also some of the aspects of breaking up larger databases, right? Depending on how the data was structured, and also how frequent certain fields were being accessed, right? So for instance, if we find a database that has a table that has several columns, some columns are have heavy traffic, but some other columns don't have heavy traffic. A very common optimization is to break those tables into multiple tables, right? Where you slice the table vertically, right, and put the columns that are frequently accessed in one table, right? Whereas the other slow performers, right, that are seldomly accessed, right, put it in a separate table, right? So that usually reduces the sizes of the table, and you can do better indexing to improve performance. So that's an example of vertical partitioning. There are different types of partitioning. There was list partitioning, horizontal partitioning, range partitioning. So this is just an example, and you have to choose, the correct one. Horizontal partitioning was common when you identified ranges of values that you could split up horizontally, right? We could put those values that go from one end to another end, right? From one range to another range, right? And split that into one table, right? That cleanly represents a subset of your data. It could be either regional, right, zip code, or area code, or right by state, by country, right? And so that was an example of horizontal partitioning. And we also talked about different ways that your code could be written in such a way that is not affected by this partition. Usually you use views to make it so that your code is how do you say, guarded from having to know that the data is partitioned vertically or horizontally, right? You create a view, which is it's a virtual representation of the underlying data. Right? This goes in the same topic of architecture and some of the fallacies that developers or engineers have on some assumptions that they might have on the architecture, that they might assume that the network latencies are negligible. So this asks you, so what's some of the fallacies? So this one says, assume the network is not secure. Now, actually, that's a good thing, right? To assume that the network is not secure. That's a good thing. So it's not a fallacy. Assume that the network is not homogeneous. That's good too, right? Assume that the network bandwidth is finited. That's misspelled. Sorry. So that's a good thing. Assume the network is reliable. Okay, that's a fallacy. Right, so this should be selected as well. So these two should be selected. Assume that the network topology might change. Yeah, that's a good thing, right? So that's not a fallacy. And replicated. Okay, so if you have a replicated architecture, right? If you remember, we saw that there was no way that we could replicate the behavior of a of software or system that is developed in running in a single CPU, right? That behavior, right, is what we would love to have, even if you distribute across multiple machines. But there's no way to replicate it entirely, right? You're always going to have certain compromises, right? That if you want in complete consistency, then you're going to have to sacrifice other things, right? For instance, you have to sacrifice availability, or vice versa. If you want 100% availability, then you're going to have to sacrifice consistency, right? That there are going to be cases where one pays for the other. So, and I give you other options here that are not valid. And that's captured all in the CAP theorem, right? Brewster's theorem. That there are three attributes that a distributed system has: availability, consistency, partition tolerance. And he says that you can have two of the three, but not all three, right? That if you select any one or the other, you need to sacrifice the other, right? So that's obviously in the slides. And it's all captured this attitude, right? That there's no way that you're ever going to match the semantics of a non-distributed system. Right? So a distributed system is never going to match the semantics of a non-distributed system. Then several questions about the RESTful architectures, right? And the different conventions that we have been using throughout the semester of using post, put, get, delete, for updating, deleting, creating, or retrieving data. Right? I can list this question. Right? If you want to retrieve grades, if you want to submit an exam, or if you want to modify a grade, or you want to remove an assignment, which HTML can you use? And so there's like a drop down, and you can select from the drop down. Also, the URLs that you would use, right? So this says, according to REST conventions, if you want to implement this use case, manager wants to retrieve contracts between a particular range of dates, right? What would you use? Well, because we're retrieving, then it would typically be a get, right? You would not be using a put or post, right? You would be using a get. So I guess it would, the answer would be between these two. Another convention is that in the URL, you only encode the nouns of the things that you are retrieving, right? And you would also include perhaps the primary keys if you are retrieving an individual instance of those nouns. So for instance, so that's the problem with this answer, right? Because notice it's encoding data here, right? Of values for min, max, things like that, right? So that should not be encoded in the URL. Instead, the convention says that you use maybe a query string to do that, right? If you so that you only for the path you only include nouns and primary keys, right? And use a path, right, to navigate from one data model to the next data model and whatnot. Yeah. Whereas you want to filter things, right? And say you don't want all the contracts. You don't want just one contract, or you want all the contracts, which that's all you can do with paths, right? But instead you want to filter it. Okay, well, I want lots of contracts, but the ones that match this particular criteria, right? And you can do that. You can encode that as part of the query string. Okay. And so this asks you, so which one would you use? Okay, so definitely not these two. So all my exams have that peculiarity that typically if you have 4 options, 2 of the options will be obviously wrong, right? So these 2 are obviously wrong. And then the other 2 are kind of like, so which one is that? That looks right. That looks right. Which one would I choose? So usually both would be okay, right? They would both work, but one usually is better than the other. So you have to choose which one you think it's better than the other. So this one is better than that. Okay. Okay. So more RESTful questions. So you have this use case of saying an artist can retrieve their drawings. So it looks like you can retrieve lots of drawings, or maybe all the drawings, presumably. And for an artist, that means that you need to know which artist are you talking about. So you need to use maybe a primary key of that artist, and then ask the drawings for that artist. So I give you 4 choices, and they probably all work. They would probably all do the job, right? But there are some conventions, right, that we use in RESTful, right? We say you can. This one, yeah, I have the idea of the artist, so this would work, right? And I want the drawings, but it does not follow RESTful convention, right? That's what the convention is, that you provide the the various nouns, and then you say noun, primary key, noun, primary key, noun, primary key, right? So this one's the one that matches. You have the noun of the artist, then you identify the particular artist, right? And then finally, more nouns, right? That and then typically you navigate from more generic, right, more general, down to the more specific, right, from left to right, right? So artists, there's lots of artists, and you specify a particular artist, and then you navigate down to the specific things about that one artist, right? So this one is you can remove a song from its playlist. So from a playlist. So a song is inside, presumably, of a playlist, and you are removing a specific song. So I need to know which playlist are you removing it from, and then which song are you removing, right? So again, right? This one is only giving you the idea of the playlist, so obviously that's not right. This one gave me the idea of the playlist, but it's not telling me which song. So this kind of like removes all the songs, so that makes no sense. This might actually work, right? Where you are removing the song itself. Actually, no, that would not work, because wait a minute, you want to remove the song? Maybe that's not what you want. Maybe you want to keep the song. You just don't want to. You just want to remove the fact that this song is in this playlist, right? So the song stays, the playlist stays, but the song is no longer in the playlist, right? So this one is, so it's a relationship between both, right? Between a playlist and a song, right? You will remove that relationship. So this one has the idea of the song, the idea of the playlist, and you're removing that relationship. So here's
Professor.
Yes.
Quick question. So I know we always had good practice where we put API first / then the noun and the key, but on like real websites and stuff, they don't use API. They would use like something else. or like what's practice in the industry?
Yeah. Yeah, you're right. That's it's we did talk about that in class a little bit. That whatever you use here, it's up to the team to
Right.
decide what is it that you want to use. You know, API is very common. REST/REST is also very common. Slash data is also very common. It usually it's only used. It's not necessary, right? All of this are conventional, but it's usually used so that it's to differentiate between static content and data, right? And static usually both are being hosted by the same server, right? And the server when you say slash and then you say tweets, do you mean the web page that renders all the tweets, or do you mean the array of all the tweets? Do you mean the data, or do you mean the user interface? Right.
Got it. That makes it clear. Thank
you.
So
to distinguish them, usually we prepend something that makes it clear that this is a data API, right? And that we are retrieving JSON objects or XML or something, and not some user representation of some screen, right? This is meant for programmatic access. It's not meant for human consumption.
Got it. That convention makes sense. Thank you very much.
So also there will be questions about design patterns. Certainly the design patterns that we use throughout the semester, we've used controllers, access objects, singleton, right? Iterators, adapters. So I will give you maybe some description of what it is that we're trying to solve, and then ask you, okay, so what example is that? Is that an example of an iterator, an adapter, a singleton, a data access object, a controller? What is it? Here's another one, right? Here I give you an interface, right? And it says, ooh, okay, so I can use this interface to implement a whole bunch of other stuff, right? Given this, I could implement maybe a queue. I can implement a stack. I can implement a circular array, right? I can implement a list. I can implement a whole bunch of other stuff using this one interface, right? So when you do that, what is that you're typically doing? That's called using the adapter design pattern, right? You're adapting one data representation and adapting it into another data representation. Okay? So also some documentation questions. Given, say I have given this use case, a bookshelf can have several books. So a bookshelf, so one bookshelf can have multiple books. So that sounds like a one-to-many, right? And so I think there was an error in this question. Okay, this is a many-to-many, so that's right. So this looks like one book can have many bookshelves. That makes no sense. Here's a bookshelf that has many books, so that's the right answer. But I think there was, I'm sorry, there's nothing wrong with this question. But there were questions that bugs in there. Oh yeah, this one for some reason displayed twice the same text. So this one asks if you have an actor can win many awards on different movies, and a movie can win many awards, right? So what UML diagram represents that relationship? And so this one was saying, I don't know if the intention was that actors award many actors and award many movies. So that's not right. So the answer was to have the award in the middle, star as a mapping class, right? That was mapping actors to movies, saying which actors were awarded what movies, and you can use this representation to ask it both ways, given the actor which which movies did they win the award for, or vice versa. Given the movie, I can give you what actors won the award, right, for that movie. This is wrong, right? We have the ones on either side. That's wrong. You have to have the star on either side. This one was okay. Yeah, this question had a mistake that it was there were two that had the same answer. This is wrong, right? Because this one's the star one and star one. That's wrong. Or one star. That's wrong too. Or individual ones wrong as well. So yeah, so that one's right. So this one, given another use case, saying, okay, so what UML diagram captures the following. So given you have an hourly employee is a special case of or special type of employee. So that's obviously inheritance, right? Where hourly employee just inherits from employee. You just go through the class diagram that captures that. That's just a simple association. That's an aggregation. That's a composite. But here's a inheritance. Now this has the inheritance on both sides, so you have to remember which way the arrow goes, right? So the arrow goes on the high level, right, on the abstract, and not on the more concrete. So the arrow goes in the base class, and the derived class doesn't have the arrow. So careful with that. So these are the examples of composite, right? Just try to pull you it's that one, right? Here's another one that says, okay, so this one says, if you remove a tweet, then all its replies are removed as well. Okay, so this kind of says that, so looks like there's a relationship between a given tweet, right, and the replies that are associated to that tweet. And this says that if you remove the tweet, that it seems like notice that it's reply. So this is kind of like an ownership relationship, right? That or has a relationship where one tweet has many replies. And so there are two ways that we can capture that. Right? We can capture it either with an aggregation or composite, right? So here's a composite of saying reply has many tweets. No, that's not what we're saying, right? Tweet has many replies. Yes, right? So that's not it. This one says that tweet has a reply. It says that tweet has replies. So that's a candidate. Not that one. Reply doesn't have tweets. A reply is a tweet, right? So that's not it. A tweet has a reply that has many replies. So that's a candidate. A reply has tweets. No. A tweet is a reply? No. Okay, so between these two, it's either tweet has a reply or tweet has a reply. Now, which one is it? Both are establishing a one-to-many between the tweet having many replies. But notice that this one says that if you remove the tweet, you also remove the reply. So this is kind of like cascade action, right? That says that there's some kind of dependency of the life cycle of one versus the life cycle of the other. Meaning that if one dies, right, the other one dies too, right? If we remove one, the other one are removed as well. So the existence of one depends on the existence of the other. And so only composite captures that, right? Composite establishes, right, that there's a one-to-many relationship between tweet, one and the other, but it also establishes the fact that the life cycle of the whole of the many depends on the life cycle of the few, right? So if you remove the tweet, that is cascaded down to the replies. Whereas aggregation says that yes, has a combination, right? But it's a reference. I have a reference to it, and that if I am removed, it doesn't necessarily mean that I remove the other, right? That I might remove the fact that there's a relationship between the two, right? And we did that before. There's another example here that we did that. Yeah, so in the playlist and the song, right? you have playlists and you have a song, and a song isn't a playlist. But does it make sense that if I remove the playlist, I also remove the song? Not necessarily, right? I just want to say that this song is no longer in that playlist. Right? I don't want to just remove the song. I want to remove the fact that they are related. Okay, so that's an example of an aggregation, right? Not a composite. Composite would say that if I remove the playlist, I would also remove the songs in the playlist, which makes no sense, right? So I would not use a composite. I would use an aggregation. Sorry, I have a splitting head. So yeah, so here I would use an aggregation, a composite, right, to implement this, right? Now, whether it's a good decision to remove the replies if you remove the tweets, that's another issue, right? If they tell you this is the way I want it to behave, right, you would push back and say, are you sure that you want this to be a composition and not an aggregation? Right? This example here, right? It's okay, well, we're saying here, even if the user deletes their account, we are actually going to keep their information, okay, which is what you would expect, Twitter to do, right? Even if you leave Twitter, does it actually remove all that information? Probably keeps everything, right? Any images, photos, videos, any relationship that I might have with other users. It probably keeps all that. It doesn't mean that if you delete your account, I'm going to just remove everything from the database, right? That it might have a lot of information there that I want to mine and whatnot, especially if you're a celebrity. So for instance, if we're so that's an example of an aggregation, right? That if we're removing the account, we're still going to keep the user information. We might sever the relationship, or we might make it dormant somehow, right? And we are going to soft delete something, right? Maybe it has a flag that says deleted, and we turn on the deleted flag. But it doesn't mean that the information is no longer there. It's still there. It's just that it's logically being removed, not this. Okay, so we use an aggregation, not a composition. Composition, you're documenting the fact that you are removing, right? That if you remove one, it cascades down to the other. So here's an example. I actually don't like this question, but where we're giving a class, right? And so the intent of this question was to see that it violated the solid principles. If you remember, solid principles was that capturing some of the object-oriented principles that are listed here, right? That it has a single responsibility, that it's open closed, right? We skipped over L, and that there's an interface segregation principle and the dependency inversion principle. Okay, we saw this early in the semester. So this question was trying to capture that, where you had a class that was doing too many things, right? Was was person, and so the person class should only have behaviors and data that are specific to the person. Okay, so we capture maybe first name, last name, date of birth, things that make up a person. Okay, and so my intent here was to add functionality for formatting that person, right? And but formatting a person is not really something intrinsic of a person or a human being, right? It's more of something that I would use when I store the user, either in a database or want to represent them in a user interface, or want to send a piece of data of that person through an HTTP call, right? But it's not intrinsic to being a human being, right? I could go on being a human being without ever having to be formatted as a piece of text or whatnot, right? So this should not live here, right? Instead, this format should be elsewhere in a separate class or separate utility function, right? Where maybe I could pass it an instance of person, and then it can format it as in different ways, format it as XML or JSON or CSV. So really, this function should not live here. So that's what the intent of this question was. But lots of people got confused with this question, so I'm not going to use this. I'm going to try and do a better job at making a better question. And the intention was that it was breaking the single responsibility principle, right? That if you see a class or function that is doing more than what its name intends, right? If the name should capture, right, what the what is the goal of this function or this class, right? And if you're doing too much in that function or that class, then you should break it up and break it up into a separate class, right? That just does that one thing, right? That should have a single responsibility, should do one thing well, right? And if it tries to do two things, well, then break it up into two things, right? Where each one does a better job. So anyway, I'll try to come up with a better question for that particular principle. And here's another one where this kind of captured the same example that we did here in object-oriented, where we were implementing. I think it was we were playing around with shapes, and shapes had a particular. Oh no, wait, no, it was I think it was graphs, right? And you want or shapes that you could translate, you can rotate, and depending on how many sides you had, you can calculate how many what was the weight of that shape, right? And we implemented it in two ways. We did it functionally using switch case statements, right? And then we did it implementing it with object-oriented way with different classes implementing the different shapes. And we said, well, which one's better? Right? And we said, well, if you are adding more functions, right, it's easier. Or sorry, if you're adding more shapes, it's easier to it's easier to do it one way, or it's easier to do another way. If you're adding more function, or you're adding more shapes, right? So if you're adding more shapes, right, it was easier to do it this way. If you're adding more function, it was easier to do it with object-oriented programming, right? And so this went back to the principle of the open-close principle, right? Where we want to implement things that are okay with they're open to extension, right? Meaning you can add more behaviors or add new shapes, right? But they're close to modification. So things that would not force you to go in and change source code that you've already written. So your code should be written in such a way that it's open for extension, meaning you can keep adding to it without having to go back to your code and having to modify the code, right? The code that you have already written, right? So this particular implementation where you have weekly pay, and you have full-time, hourly, employee, but then you also have all these functions, right? Weekly pay, you also have monthly pay, yearly pay, bonus pay. So the question is, well, what does this violate? Which one does it violate? Well, it violates open-close because if you want to add a new type, if you want to add a new type of employee, you're going to have to go back and modify this switch statement, right? You have to modify the switch statement that with a new type of employee, right? And you're also going to have to modify monthly pay and yearly pay and bonus pay. They're all going to have the same switch case, right? That you have to add this new employee to these 4 different functions. So you have to modify code that you have already written. So it breaks the solid principle of open-close, right? Instead, if you would have implemented it using object orientation, you can inherit from the base employee And you don't have to touch all the other implementations, right? You can just focus on this new type of employee and implement all the functions within that one class, right? By extending, prior implementations of employee, you're just going to add, right, new implementations of monthly, yearly pay, bonus pay, and weekly pay within that one class, without having to go back and re-implement any of the other classes, right? And touch any of the source code. That makes sense. So that's why object orientation, of implementing interfaces or inheriting and whatnot, right? It does not break the solid principles. Okay. So anyway, so that's I think what you can expect. Obviously, it's not going to. I would say there are going to be a couple questions that I'm gonna reuse from here. Probably, obviously, I'm going to reword it, give it different snippets of code, obviously, but you can certainly expect several questions from here, probably verbatim. Again, tweaked here and there, but inspired by these questions quite a bit. As you see, a lot of these are very verbose and read and just pick out an option. So these go quickly, right? These questions go quickly. The exam will be 100 minutes long, and I will make the exam available on Friday, probably in the afternoon, around this time, and you'll have, it'll make it available throughout the weekend, so you'll be able to take it either Friday night, Saturday, or Sunday.
Will it be available Sunday midnight? Could you say?
Yes.
Last time Friday to Sunday 11:59.
Yes.
So, but does that mean that that's the latest time to submit, or we should do it 100 minutes before, 11:59 on Sunday?
Well, I'm not quite sure what Canvas does with if you're in the middle of the exam and you so I would not risk it. I would give you ample time before midnight, Sunday midnight.
Okay.
I think Canvas actually kicks you out if your time runs out at midnight, even if you had like 30 more minutes or something.
Oh wow, yeah. So yeah, I would not risk it. I'm not quite sure. I've never taken an exam. That close.
I have a question for the project deployment. Do we have to deploy it on Netlify and also Heroku?
No, I'm gonna remove that requirement. If you've done it, that's great. But I'm not gonna penalize you if you haven't been able to.
So the only thing you want us to deploy to is the Mongo Atlas, right?
Yeah, that would be awesome. Yes.
Great. Thanks.
How many questions is the final going to be?
Between 30 and 35.
Okay.
I'm also going to provide with a checklist for the project, which is basically going to be the requirements document, but in the form of a checklist, just so you know that you've worked through all the requirements. So
sir,
forthcoming later.
Sorry, quick question for the exam. I mean, I know it's going to be the weekend, but if we had questions on any question, like a clarification thing, do we just post on Piazza? Will there be TAs just generally looking on there?
Yeah, we will be monitoring, and we will be available during these hours, right? If you want to take the exam at 3:30, we will be available on Zoom if you have questions.
But,
Live
but only for Friday. Yes.
only Friday at 3:30.
Okay.
But then yes, but we will be monitoring for questions on Piazza, and we'll be answering them as quickly as we can.
Like over the weekend, or also only on Friday?
Yes.
Oh, okay. So
But, we can't guarantee turnaround. That it would be an immediate turnaround.
is there a good time then to post? Like if you wanted to, set up our schedule such that it would be a good time to post questions on Piazza on like say Saturday. Should we do it around like 1 p.m. or I don't know, like
I'll come up with times where I will be actively monitoring. I'm not quite sure. I need to ask my wife what
Okay.
schedule this weekend. But yes, there will be times where probably it'll be like early in the morning,
Mhm.
9-ish or 10-ish, where we will be most available to monitor.
Okay.
But
Thank you.
I'll let you know. So one thing that has been a confusion. So for the project, we're going to be doing demos this semester. Last semester we did recordings, so students submitted a recording of them demoing the project. This time around, there's no requirement for video recording. Instead, you'll demo it live to myself or the TA. And so we'll ask you questions, and you'll go through the demo. So no requirement for a video recording.
So, is the demo going to be over Zoom, or do we need to be in class? Oh, okay. Great. So then we don't need to come at all in class then next week. Okay.
And we'll post a registration sheet where you can teams can register when they want to demo throughout the week. So probably we'll have 3-4 demos a day. So that'll take us maybe from Monday through Thursday. And so 4 teams demoing a day. So we should have all the grades for them for all those projects by Friday.
Sounds good.
All right.
Professor, do we still also have a README, a feature design documents, as well as like the self-reflection document?
Yeah, no, that was when we have video, and it was kind of more asynchronous. The classwork was more asynchronous. This time you're just gonna do the demo to us.
So like no UML or like class diagrams.
Yeah, let me update that. I'll update.
Okay.
That.
I also had one more question. When are all like the grades need to be finalized? I'm only asking because I'm still sort of waiting on my grade for assignment 2 and 3. So I can't like predict what my final grade will be at this point.
So assignment 2, I think they all went out. Although I did get some message from 2 students that didn't get. Maybe you're one of them.
Either.
Yeah, Professor, even I haven't gotten my assignment to grade yet. I asked the TA, she said that it's still to be graded, so I'm not sure.
All right, I'll check on that. All the grades, all up to assignment 3 should be done this weekend.
This weekend. Okay, great. Thank you.
Professor, do we also need to check for the ES linked related errors? I saw these like on the deliverables page.
I'm sorry, say again.
Like as in, I saw there's some mentions of ES linked warnings and errors. Like, do we need to look into those for the final project?
Yes, yeah. So make sure that you don't have any linked errors. Anything else? Yeah, I'll update the deliverables documents today. And I'll share a checklist for everybody.
Professor, I have one more question. Just want to double check on the deliverable. It says each of us need to submit the individual reflection. That's still required, right?
No, not anymore.
Not anymore. Okay, thank you.
Well, actually, I just realized something. I think someone on Piazza wrote something about Jira not working anymore. I didn't check Jira today, but
That it should be up and running again. I paid for Jira.
oh, okay, all right, cool.
Yeah, they were asking for a payment.
All right, thanks.
Okay. All right. Thank you all. I'm gonna go hit the bed.
Thanks, Professor. Hope you feel better.
Thank you, everyone.
Thank you, Professor.
Goodbye. Good night.
Good night.